Hello my dear students, this is Akash SD and welcome to the SD Physics classes. I hope so you all are doing really great. So students, in this video we are going to learn about the integral calculus. Okay, and here we will learn two types of integration. One is the indefinite integration and the other one is the definite integration. Okay, because this integration topic is very important in 12th, because whenever variable quantities are involved or the non-uniform distribution of charge is there, so in all of them we have to use the integration. There is no other way. Okay students, so very important topic. Let's start it. So here you can see very well, integration means summation. Okay, and see, it is the reverse process of a differentiation and its symbol is what? This is the symbol here. So you can see the first alphabet of the summation S, and this symbol is the very similar. That's why the integration means what? Summation. Even when we have to calculate the area under the curve, in which no formula is working, like triangle, half base into height, now all these formulas are not working. So there what we have to do, we have to use the integration only. Okay, so see now. So first one we are going to see what? Indefinite integration. Let's see. Consider a function fx whose derivative with respect to x is equal to f dash x. Then you can see integration of f dash x dx plus c is called integration of f dash x, where c is called constant of integration. Okay, maybe definition is looking somewhat tough, but see here please. What I am telling you, let's take here for example one function fx is there. Okay, so when we are doing that differentiation of fx, what we are getting? We are getting here f dash x. Even this is called a first derivative of fx also. So when you will go in a reverse direction, that is called the integration. That's why we are telling integration is what? A reverse process of the differentiation. Okay. Similarly, if in case see, if I write here in a mathematical form very properly, so here this f dash x is given by d by dx of fx. Okay, this is the differentiation. That means we went from left to right. After that, if we do here the reverse, that means just do the cross multiplication and all, then you can write here, see, this d of fx. This d of fx will become what? It will become here f dash x into dx. Okay, then we'll put the integration both the sides. So what this will come here? We can write here, see, this fx is equal to integration of f dash x into dx plus c. Okay, so this I am talking about. Now after that, if I talk about here one more thing, even in physics also, even in physics also, what will happen? Let's take position is given and we want to calculate the velocity. Here also we have to do the differentiation. If velocity is given, we want to calculate the acceleration. Here also we have to do the differentiation, but in reverse direction, like acceleration to velocity, integration, velocity to position, integration. That's why this integration topic, students, this is very, very important. Is it? I hope so. You have understood very well. Next one after it, students, we are going to see here one formula. So multiple formulas are there, but we will see only definite means some formulas that is important for the physics. Okay, so see, the first formula is the very, very important. If we are doing here integration of the dx, so integration of the dx will be what here? X plus c. Now, and let's take for example, if we try to understand this. So let's take for example, here I have taken one rod. Now, what I have taken here, I have taken one rod. Now, and let's take here, this is having small sections. Now, because a rod can be considered to made up of small sections. Let's take this is dx1, this is dx2, this is dx3. Now, similarly dx4, dx5, dx6, like that. So many is there. Now, dx7. So here, if I write here with the example, so what this will happen that here, if I want to write here the total length of the rod, now I told you now integration means what is summation. So total length of the rod will be what here? If I write here, see, x equal to, I can write, see, sigma I equal to 1 to 7 dxi, if it is made up of 7 segments. But if it is made up of so many segments that in a continuous manner we can write here, see, x means integration of the dx. Now x means what? Integration of the dx, and one constant also we have to use depending upon this situation. Okay, depending upon the situation. That's why we are writing integration of the dx means what? X plus c. Is it? I hope so. This is very clear. Similarly, students, after that, if we talk about here the second one, what is there? Example. Now, let's see here the example. Okay, so see, if I take students one more example, this is the first example now. Let's see the second example. So here what is happening, that let's take for example here also. I have taken here this x, this y, and here some curve is there. Now y equal to fx curve. And I want to calculate the area under the curve. What I want to calculate, students, I want to calculate the area under the curve. Then what will happen that here, see, here multiple segments I will take here. Let's take for example, this is the dA1, this segment dA2, this segment dA3, this segment dA4. Okay, so if I write here the total area, so what total area will come? Sigma I equal to 1 to 4 dAi. Is it? If so many, no, this area is made up of so many small strips, then what we can write here? We can write here this A means integration of the dA. What is this? A means what is, students? Integration of the dA. Is it? And even in this also, even see, this is the real situation. It's okay, no need. Later we will understand when to add the constant and when not to add the constant. Is it? So I hope so. This is very clear. Now, after that, some other basic formulas are there. So see, second formula. Second formula, if I write here, see, x to the power n dx. So x to the power n dx, what will come? X to the power n plus 1 by n plus 1 plus c. Is it? And if I talk about here some examples, let's take, if it is given here, integration of x dx. So what is there here? Here x to the power n 1. No? So we can write here, see, x to the power 1 plus 1 by 1 plus 1 and plus c. So what we can write here, x squared by 2 plus c. Is it? Similarly, let's take here, one more is there. No? This is A. No? B. Let's take, if in case it is given here, see, let's take y square into dy. In any form they may give. Okay, so what will become here? Y to the power 2 plus 1 by 2 plus 1 and here 1 constant. So what we can write here? Y cube by 3 plus c. Is it? Very clear. After that, let's take here, for example, we are doing integration of the sin x into dx. So what this will become here? Minus cos x plus 1 constant of integration. And fourth one, if I am writing here, integration of the cos x into dx. So what this will become here? It will become here sin x plus c. Okay, at least this 3-4 formulas you should remember that to mostly questions will be solved. Okay, now we are seeing what is the importance of the constant of integration. Now, because in indefinite integration, whenever we are doing the integration, we are adding plus c. Is it? So what is the importance? So here please see. Prove that integration is the reverse process of a differentiation, and this one we are going to see this function to prove it. So you know very well what is the basic. If fx is there and we are doing the differentiation, what is coming? It is coming here f dash x. And when we are doing the integration, we are reaching to the reverse. Okay, so first we are going in a forward direction. So what will happen that here, see, this f dash x is given here d by dx of fx, and fx how much given here, see, 4x cube plus 5. Is it? So here what will happen that here, we can write here 4 into d by dx of x cube plus d by dx of 5. Now, so here what will happen that here 4 differentiation of x cube will come here 3x square, and differentiation of constant is 0. Why? Because which formula I am using here? I am using this formula, d by dx of x to the power n means nx n minus 1. This is one formula. Okay, and one more formula is there, this one, d by dx of any constant is 0. Okay, differentiation we have learnt in a last video. So anyhow, what this will come here? It will come here that 12x square. What is coming? 12x square. Is it? Now after that, what we are going to do here? Now, from fx we have got the f dash x. Now we have to go reverse. Then only we can prove. So what we can tell here? See again, as I have told you very well, this fx is given what here? Integration of f dash x into dx here. Is it? And plus c you can add after the integration. Now again and again no need to add, just at the end just add it. Okay, that's it. So what this will come here? It will become here f dash x. That means we can write here what is there? F dash x 12x square. So 12x square into dx. So anyhow the 12 is constant, that will come outside here, and here what will become here? X square into dx. So this will become here 12x cube by 3. Now then we'll write here plus c. So what will happen that here, this fx will come what? This fx will come here 4x cube plus c. Now you can see why this c is there, because see, when we have done the differentiation, that this 5, it has become 0. So to recover that 5 we have added c. Okay, now after that in this what we'll do here, we will use here the initial condition. What is the initial condition? f0 equal to 5. So if I write here, see, this f0, that means x value you have to put here the 0 and plus c. So from here, what c is coming here? Students, c is coming f0. What c is coming? C is coming here f0. And what is the f0 value is here? 5. Okay. So this is the value of c. So if you combine both of them, now see, if you combine this, so anyhow what fx is coming here? This fx is coming here, you can see very well, 4x cube plus 5. Now you have understood very well what is the importance of c, because whenever we are doing the differentiation of constant, it is becoming 0. So to recover that again after the integration, we are adding here the plus c. Is it? That is the basic concept under the integration. Okay. Now students, after that we are going to see this NEET and J. Important for that. Now so here please, we will divide it into the two parts. Now so integration of x square into dx minus integration of cos 2x plus 3 into dx. Is it? So you know very well here, integration of x square dx means anyhow 2 plus 1 by 2 plus 1 minus integration of cos means sine. So what is coming? Sine 2x plus 3. And remember that here, this is called in differentiation we have learned the chain rule. Like if instead of x any other thing is written, we have to do the differentiation and multiply with that. But here what we have to do? We have to do the differentiation of this 2x plus 3 and we have to divide. This concept we will use in a trigonometric function, logarithmic function, exponential function and all that. Okay. So what this will come here? Anyhow here plus c will come. So we can write here what? It will become here x cube by 3 minus, it will become here what? See, sine 2x plus 3. And anyhow what this will become here? This will become here 2. Now differentiation of 2x plus 3 and here plus c constant. Is it? So I hope so. This is very clear to you. Is it? Great. Now after that, see here, integration of sine square x dx. This kind of function will be very important when we are dealing with AC, alternating current in 12th. Okay, but still we'll see here. So to solve this kind of question, first we have to use the formula you know very well. Cos 2x means 1 minus 2 sine square x. Okay, so from here, if I write here the sine square x, what this will come here? It will come here 1 minus cos 2x by 2. Is it? This value I will put here. Now, so what we can write here as, I can write here now, integration of sine square x into dx. What this will become here? Integration 1 minus cos 2x by 2 into dx. Is it? Now after that, just see here 1 by 2 cos 2x and into dx. Now after that, students, just separate it here. So dx will go inside, so half, it will become here dx minus half, it will come here what? Cos 2x into dx. Is it? Now after that, what we can write here? We can write here, see, integration of the dx means what? X. So it will become here x by 2 minus 1 by 2. Now integration of the cos 2x, it will become here sin 2x. Okay. And again, as I have told you, now again I will not write here, but again I am writing here, see, d by dx of 2x. Again we have to divide it here, plus c. So what this will come here? Students, see, this will come here x by 2 minus sin 2x by 2 is here, and d by dx of 2x again 2. So 2 into 2 will become what? 4 and plus c. Is it? I hope so. See, we have done the sin square x. Okay, great. Next one is, students, see. Now after learning the indefinite integration, like when we'll do the integration, one constant of integration will come. But here definite integration, that means when we are doing the integration from one lower limit to the upper limit. Okay, first let's go through it. So see here, in this integration, if function of f dash x is integrated between a lower limit and an upper limit, that means from x equal to a to x equal to b. So students, here this x equal to a is the lower limit and this x equal to b is called which limit? Upper limit. Okay, so see here please, here we know very well now. So see this as we know very well here, see here students, see this fx is what is this? Integration of f dash x into dx, correct? And here we have to add here the plus c. Is it? So this one we have done here what? This one we have done here, students, this one we have done here in indefinite integration. What we have done? We have done in a indefinite integration. But if we do here the another one, like see this one here, fx, and here what we are doing here, we are doing f dash x into dx, and lower limit, what is this? X equal to a, and upper limit, what is there? X equal to b. So when we are doing the definite integration, that time what will happen that here, no need to add plus c and all that. Okay, here what will happen that here, see, again I'm writing a c fx. What is coming a c? What is coming? Fx. No, and we'll write here x equal to a to b. That means it will become here what? It will become here fb minus fa. That means first you have to put the upper limit, minus you have to put what? You have to put here the limit, lower limit. So here this fx will come in terms of the some variable x and all, but here as we are putting the limits, so this fx at the end, it will come here some numbers, because we are putting here the limits and all that. Okay, and students, this one is coming under what? This is coming here under the definite integration. Is it? I hope so this is very clear. Is it? Great. Now students, after that, let's move to the next one here for the NEET and JEE. Now see here. First one. Here you can see the definite integration is there. Now see, x equal to 1 to 2 x square plus 3x minus 1 into dx. Now very easy. So see here please. Directly I am writing here, see, integration of x square into dx plus 3 integration of x dx minus here dx. Okay, and limits where to where? See here, the limits x equal to 1 to 2, and here also x equal to 1 to 2, and here also what is this students here? X equal to 1 to 2. Now these are the lower limits. This is the which limit? Upper limit. So what will happen that here, integration of x square dx will become here what? X cube by 3, and here 1 to 2 minus 3 integration of x dx, how much here? X square by 2, 1 to 2 minus integration of dx means what? X 1 to 2. Is it? Now students, here this 1 by 3, first you put the upper limit. So what this will become here? 2 cube minus lower limit 1 cube minus 3 by 2. Now take this 2 denominator outside. So this will become here again 2 square minus 1 square. Is it? Minus. After that again you put the lower limit, 2 minus 1 minus lower limit. Is it? Then you can simplify this very well and you can get the. Is it? After that, what is given here? See, 0 to pi by 2, we have to do here the cos square x into dx. Okay. So anyhow, no need. Okay, here itself will do here. No, here is space is there. No, this side will do here the second one here. No, so see this one, second one. Remember that here, as you have seen that like cos 2x equal to 1 minus 2 sin square x. So similarly, one more formula is there for the cos 2x. Cos 2x means 2 cos square x minus 1. Okay. So from there, if you will write that, then what will happen that here, this cos square x, we can write here 1 plus cos 2x by 2 into dx. And limits where to where? 0 to pi by 2. Okay, then again after that kindly separate it here. So what this will become here? 1 by 2 integration of the dx where to where? 0 to pi by 2 plus, and what this will become here? 1 by 2 integration of cos 2x into dx, and again where to where? 0 to pi by 2. Is it? Now after that, say here this half integration of dx means what? X 0 to pi by 2 plus. Now again integration of the cos 2x sin 2x, and remember again we have to divide by 2, and now you are well intelligent enough and you can get it very well. And see, one more 1 by 2 is there outside, don't miss it here. Okay, this here 1 by 2 is there. Is it? This 1 by 2 is there. Now this 1 by 2 I'm talking about here. Okay, and here what is this? 0 to pi by 2. So what this will come here? Half, and it will come here, see, upper limit pi by 2 minus 0 plus this 2 will come outside, so 1 by 4 here. Okay, then again you put the upper limit first, so sin 2 into x value pi by 2 minus sin 2 into 0 anyhow. Is it? So what this will come here? It will become here what? Pi by 4 now plus 1 by 4, and here 2 into pi by 2, 2 cancel. Sin pi means sin 180 0, and here anyhow what is there? 0. That means what is coming here? It is going to come here pi by 4. Is it, students? So I hope so you have understood this very well. Now what we are seeing? We are seeing here the definite integration. Okay, great. Now after that we are coming to here now, as I have told you now, like what is the graphical significance of the integration? The graphical significance of integration is the area under the curve. Like for the differentiation, the graphical significance is the slope. So similarly for the integration, what is this? Area under the curve. So see, one more application also. See, calculate area under the curve y equal to x square and x-axis from x equal to 0 to x equal to 3. So what I will do here? Here I will take here the, see this one here, this is x, this is y, and here and you can see the graph will be what? A parabola, because y power 1 and x power 2, and this graph will be open towards which side? Power 1 side here, that means towards y-axis. So if I draw here, it will come like this. Now like this it will come here. After that, if I just see here the some values, let's check here. At this point, what will happen? The value of x will be 0, and here if I take here, the value of x will be what here? They have told 3. Now, so even if you put also here, you can see here, this is y equal to 0, and here what will happen? Yes, guess, students, this y will come what here? Just put here 3 square, what will come? 9. Okay, and now what we have to do? We have to calculate this area under this curve. Okay, so as we have to calculate this area, what we have to do? We have to take here very small strip, very small strip, because variable things are involved, so see here, very small strip here. Okay, let's take height is y, and this thickness is water dx. Okay, so what we can write here? See, we will write here the area of strip. What is this? Area of strip. It is given by dA equal to y into dx. Now this y, this is dx, we are considering just like a rectangle. Okay, now after that, again what we can write here? This area is made up of so many small strips. Okay, so if in case I want to know here the total area, so what this will come here? Integration of the dA, where to where? Lower limit x equal to 0, upper limit x equal to 3. From here to here, all the strips we have to add it. Okay, that means what will happen at here? See, x equal to 0 to 3, dA. What is the value of the dA? See, we have got it very well, y dx here now. So y into dx. After that, we can write here, see, integration. What is the value of y? See here, x square dx. No? X square dx, limits where to where? 0 to 3. After that, integration of x square dx, what you write here? X cube by 3, and put the limits here, 0 to 3, that means here 1 by 3 outside. First upper limit, that means 3 cube minus 0 cube. Okay, so 3 cube by 3, anyhow 3 square, that means what will come? Here it will come here 9, and area means 9 unit square. If in case here it is given meter, means meter square, centimeter means centimeter square, no unit means we will write here the unit square. Is it? Kindly see very well how we have got here the area. And remember that here, if in case under the extra I am telling that here, if in case they told y equal to x square and y axis, if in case they told this area, then you know what we have to do. In that situation, you have to see here, strip this side. I am telling you, see, this strip you have to take. Okay, and what will happen that here? This side you will take here the dy, and anyhow what will be there? This will be the x. Okay, so in this situation, if you write here the area, and I am telling that here, now this one here under the extra. So in this situation, you know what this will become here? It will become here x into dy. And what will be the value of x? The value of x will be what? Root y into dy. Now because we have to do integration now, root y into dy. And from where to where you have to put the limits? From y equal to 0 to y equal to 9. Y equal to 0 to y equal to 9. Then what will happen that here? In this you will get here the area between the given graph and the y-axis. Is it? So depending upon the situation, you have to do it. Okay, great. Now after that, the last thing is what here? This is the last thing. See, last thing. Calculate area under the curve y equal to sin x and x-axis from x equal to 0 to pi. Is it? So what will happen that here, students? See, here I have taken here, anyhow this is the x, and this side this is the y, and what is the graph is there? The y equal to sin x. So I hope so little bit basic idea you have for the graph here. Sin x graph is used to be something like this. Now like that it will keep on continue with the period of how much here? The period will be the 2 pi. So 0, pi, 2 pi, and here the maximum value of the sine function plus 1 and minimum value minus 1. So what we have to do now? We have to see this area. Now this area we have to calculate. Okay. So again what we'll do here? See, again we'll take here one strip. Okay. Height is y, and this much how much is there? This is dx. Okay. So again the first step we have to write here the, see, even area of the small strip. So what is the area of the small strip? Now you are well intelligent enough, dA equal to y dx. Okay. After that, next step, the total area is given by, what is this? Y dx, where to where? Limits, see here. Here at this point x equal to 0, and here what will happen? X equal to pi. That means we have to integrate from 0 to pi. Okay. Now students, after that, see here 0 to pi, what is the value of the y? Sin x. So sin x into dx. Now integration of the sin x minus cos x. No? Minus cos x, and here 0 to pi. Okay, then after that what this will be considered here, see this area A will come here, minus is outside, and here anyhow cos x 0 to pi. Okay, so here the minus, then what we have to do, we have to put the upper limit, so cos pi minus lower limit cos 0. Okay, so here minus value of cos pi, how much is there, minus 1, and value of cos 0, how much is there, value of cos 0, 1. Okay, so you can see very well when you will solve this, it will come here 2 unit square, is it? So you can see very well, students, how we have seen this area also. So students, in this video we have learned all these basics of the integration and all that. Okay students, keep studying.